Example 2. Electricity. An alternating current I in amperes and a certain a circuit can be found after t seconds using I equals 4 sine 255t, where 255 is a degree measure. Rewrite the formula in terms of the sum of two angle measures. Okay, so basically what we're trying to do is, could we solve this in some way where we use hand trick values? And 255 is not a hand trick value. So what I'm going to do is just kind of first just remind ourselves of what values we could use and how we would get there. And so I usually use a first quadrant plus something else that works. So in this case, if I have a y-axis here, x-axis here, we know that a y represents 90 degrees. This would be 180. Let me put 90 there. This is 270, the negative y-axis. And this right here would be 0, comma, also it would be 360 if you went all the way around. Okay, so 255 is somewhere over here. So we got to find two. I want to use first like hand trick values. And so the hand trick values, if you remember, are like 30, 45, and 60. So if I went over to 180, I could do 30 more, because that's one of our values, which is 210 degrees. And how many more would I need to get to the 255 that ultimately I want to get to? Is, let's see here, if I ultimately want to get to 255, and I already have 210, I'll put 255 down here, then what I need to add is 45 more. And so I'm going to come here and put 255 here. And so we need to have here 45 degrees. So that's what I'm going to do. I'm going to say that this value is the same thing as saying I equals 4 sine of 210. I'll do this in red so we can keep track where I'm getting these values, of 210 degrees plus that green 45, and I'm going to do this 45 with the t there. Equals that. Now let's go back to our sine formula, and so we can use a formula. Oops, sorry about that. And I'll click it here. And when you go to sine, that we see that the angles, the sign stays the same, the symbol stays the same. So since we're adding 210 and 45, it'd be sine A cos B plus cos A sine B. And so here we could rewrite it if we wanted to simplify this. We could say that this equals I is 4 sine of 210 degrees, and then it would be cosine of, and I'm going to put 45 degrees t, like that, plus 4 sine, no, cosine comes first this time, I'm sorry, cos of 210 times sine of 45 degrees t. All right, because I put the t right there with the 45. That's how I chose to do it. Now, if you want to simplify this further, we could find out that sine of 210, again, that's like a 30-degree reference angle here. So that's 30 degrees past. So 30 degrees, you would be using, and I'm going to put up this up here, that all students take calculus, which tells us the sine and cosine, they're both negative here because I have a negative y and I have a negative x. So sine of 210, you'd bend your 30-degree finger, which is your ring finger, and you flip it, and you'd find out that this value is the square root of 1 over 2. And over here, this would be, since x is on the bottom, it would be square root of 3 over 2, because I have 3 fingers here below the bend, I have 1 finger above the bend. So if I really wanted to reduce this one more time, I could say this is 4 times square root of 1, which square root of 1 is a half. So 4 times 1 and a half gives us 2, so this would be 2 cos of 45 degrees times t, plus, over here, I could just reduce the 4 and then divide it by 2 and give us 2, but the square root of 3 does not reduce. So the 2 square roots of 3 for all this value, sine of 45 degrees t, just like that. That would be my answer here. Now let's check out this next one. And now it says what would be the case if it were after 1 second. So I'm going to take this same formula that I just wrote down here, and I'm going to copy it. And so here's my formula, and now we're saying that t is 1, so 1 times 45 degrees. That just basically goes away. So if I want to do this again now, I need to go to the hand trick. 45 degrees is my middle finger. And you know what? I need to come back here. I forgot to do these negative. Let's go back and change that really quickly. That this needs to be a negative here because it's in the third quadrant, and this value is also negative, which means this becomes, when you multiply it, a -2 there, and this is also a -2 because they're both negative. So plus a negative is simply just a negative. So let's erase that and put a negative there. And this is because 210 is, I'm going to do Q3 for quadrant 3. Okay, so let's come back over here, and we've said this is now negative, and this is also negative here. Okay, so now let's solve this. And so we go our hand trick is 45 degrees in our middle finger. We take it, bend it, and find out that this value right here is the square root of 2 over 2, because cosine's bottom finger, so I have 2 left over. And this value also is square root of 2 over 2, because that's what I have for the top. And so I'm going to multiply this one by the -2. I'll pull that down in black. So it'd be -2 times this, and over here, minus 2 square root of 3 times this. And so if I want to simplify, these 2's will simplify out, these 2's will simplify out, and so I have negative square root of 2 minus, this would be square root of 3 times square root of 2 is square root of 6. That's the value I'm getting for our I. Now let's check our answer, because we've done a lot of work here. And so basically we want to know if this is equal to that with t being 1. So I'm going to go over here to calculator and type in 4 trig sine of 255. I'm going to press the degree symbol because we know t is 1, and so it would be just times 1, which really won't change it, but I'll do that right there just so you can see. If I type that in, press enter, I get this value, and now we're going to hope that that is the same thing as negative square root of 2 minus the square root of 6. And it is. So we did do it, in fact, correctly.